That was soft. Okay, so today we're going to talk about the surface area and the volume of cones, okay? Surface area because it's a little weird. It's a weird shape, right? We have those curved faces like that. And then volume of cones kind of comes from what we were talking about there. So find the surface area of a right cone, find the volume of cone, and then use that volume for fun. So the surface area of a cone, we're going to split it up, okay? So we have two faces basically, right? We have the cone part, and then we have a base, that's a circle. So what's the area of a circle?
Pi r squared.
Pi r squared. So surface area, the first part of our surface area formula is pi r squared. Okay, now we have to add the area of that figure there. What do you guys think?
One-third of the height.
1/3 of the height? I don't think so.
Can you repeat the question?
So how are we going to find the surface area of that round part? Like the party hat part of it.
Times the slant height. I don't know.
That was a good guess. With reading stuff up there. Okay, so if you unroll that, you're going to get kind of like a Pac-Man looking deal. Okay? So if you want to find the surface area, what you have to do is you can't just take pi r squared again, right? Because that's not a full circle. But we have this thing called the slant height. So this part we're adding is going to be pi r and then the slant height. So pi r squared plus pi r L, and L stands for slant height. So this is different than the height of the cone. Remember we talked about height the other day as like the perpendicular distance from the ground to the top, right? You stand up straight, okay? The slant height is going to be like if you're trying to walk up the cone, okay, how far that is. Okay, it's the hypotenuse if you drew this as a triangle, right? Okay, so let's talk about that. So we want to find the surface area of a right cone. Do we have R? Do we have the radius?
Yes.
Do we have the slant height?
Yes.
Yeah, so we're good to go. So surface area equals pi r squared. R is that 4 or 6?
4.
4. Plus pi times r, which we said is 4, times L, the slant height, which is this part here, which is 6. Okay? 4 squared is 16, so you have surface area equals 16 pi, plus 4 times 6 is 24 pi. What's 16 pi plus 24 pi? 40 pi. Okay? So if it asks for it in terms of pi, or if it asks for the exact answer, obviously that's when you're going to give. If you find an approximation, what is 40 times pi?
125.66.
Cool. So that's the surface area of the cone. Okay?
How do we label that? It just cubes it?
Oh, hey. Okay, I made a mistake. What's area? Is that a cubic measurement or square measurement?
Oh, it's
Square.
Squared. So instead of cubed, these both have to be squared. Thank you. Okay, try that next one. My calculator's still not working, so Surface area, what you guys get as an approximation? 436.18? 436.18. Okay. Plug in your R, that was 7.8. Plug in your slant height, which is 10. Multiply that all together, add the rest. You got 436.18. And our unit is going to be meters squared. Exactly. Okay? So this is just hypothetical, but if they gave you the height of the cone, how would you find the slant height?
Oh, Pythagorean theorem.
Pythagorean theorem, right? You know the radius, you know the hypotenuse, so you can find that other side. Or you know the height, you know the radius, so you can find the hypotenuse. Okay? So, volume of a cone. If we think back to the bell ringer there, okay, the difference between a prism and a pyramid was 1/3, right? It was the same formula, just the pyramid was 1/3 of it. So what do you think with the cone?
Same thing.
Same thing, just 1/3 of it, right? So the volume of a cone, we're going to get V equals 1/3 pi r squared h. Okay, and this is still volume equals 1/3 area of the base times the height. But we know the area of the base, so we can write it as pi r squared. Okay. Now here you don't want to use the slant height. So when you're talking volume, make sure you're using the actual height.
Okay.
Okay. All right. So finding the volume of a cone. We have a cone that is 2.2 centimeters for a radius and 4.5 centimeters for the height. Is that the slant height or the regular height?
Regular height.
Regular height, okay? So we got volume equals 1/3 pi times r squared. R is 2.2. And then times their height, which is 4.5. You guys get 22.81 centimeters cubed. I agree. So volume is going to be 22.81 centimeters cubed. All right, any questions so far? No. Okay. So we got the cone there, 5-meter radius, 8 meters. Is that the slant height or the actual height?
Actual height.
Is it?
No, because it's, wait, which one are we talking about?
The 8 meters. Is that the slant height or the height?
We don't know. It can be, I guess it's slant.
It is a slant height, right? Because it's right here on this, like if I extend that, okay, it's right there on the hypotenuse. So how do you find that? Hannah said it earlier, right? Pythagorean theorem. Okay, so we're going to have 8 squared minus 5 squared, and that's going to equal our height squared. No, 8 okay, so you guys are right. So 5 squared plus h squared equals 8 squared, right? So I just went a step ahead. I subtracted 5 squared from both sides. Okay. So 8 squared minus 5 squared, you get 64 minus 25 equals h squared. That's going to give you 39 equals h squared. How do you get rid of a square? Square root, right? Square root both sides. Those will cancel. I would leave the height as the square root of 39, so you get a more exact answer. Okay, so now we know this measurement here is square root 39. Now we have everything we need, right? We have the height, we have the radius. So volume is going to be pi r squared h times 1/3. So volume equals 1/3 times pi. That doesn't change. What do we say our radius was? 5. So times 5. And that's squared. And then times our height, which is the square root of 39. Can you what?
Square root of 39 and then 3.
I try to keep it as exact as possible. So I type it in like that. Otherwise you might get a rounding error on the assignment later. So what'd you guys get? 163.49. I agree. Volume is going to be 163.49. And what are our units going to be? Meters cubed. All right. What does it mean to be a similar figure? Like what were similar triangles? How do you get a similar triangle? Same shape, different size, right? And they have to be proportional. Okay? So same idea here. Okay? The only difference is now we're talking about our volume has to be in proportion, which takes into a length, a width, and a height. So if we want to look for a proportion there, we have a radius of 3 on cone A. A equals 3. Cone B, whoops, that says comb. Cone B equals 9. Okay? 3 divided by 9 is 1/3, right? Okay. So if you want to go from cone B to cone A, you have to times everything by 1/3, right? For dimensions. Does that make sense? Okay. If you want to go from cone A to cone B, what do? Times it by 3, right? Okay. So B to A is going to be 3. So let's use this one because that's what we want to do, right? We want to go from A to B. Did I say that backwards? Yeah. So we want to go from cone A to cone B. So in order to do that, we're going to have to times this one by 3, right? Okay. So that would be, the 3 would take care of our radius, or timesing by 3 would take care of our height, but it doesn't take care of both of them. Okay, so really what we have, we times by 3 times the length, times by 3 by the width, times by 3 by the height, if you're talking about like the 3 dimensions, right? Yes. Okay. Okay. Follow along, it might make more sense, okay? So, multiplication's commutative, so I can rewrite this as 3 times 3 times 3 times length times width times height. Okay, length times width times height is just volume, right? Area of the base times the height. So I can write that as volume. 3 times 3 times 3 is 3 cubed, which is 27. Okay? So if we want to go from the volume of cone A to the volume of cone B, we have to times by 27, not just 3. Okay? So give me thumbs up, thumbs down. Thumbs up if you're like, yeah, got it. Thumbs down if you're like, okay. All right. So the basic idea is it's easier to look at with a prism. Okay. So if I have a prism, okay, I have a length, I have a width, and I have a height, right? Okay. Now the volume of that is length times width times height. Now if I want to say, okay, I've got this prism, this one over here is 3 times as big. Okay. I can take this length and I can multiply this side length by 3, right? If this one's 3 times as big, it's going to be 3 times as long. Follow me so far? Okay. Now it's also going to be, because they're proportional, so everything is going to be in that proportion. It's also going to be 3 times as wide, and it's also going to be 3 times as tall. So if you're multiplying 3 times the length, and 3 times the width, and 3 times the height, you're really multiplying by 3 times. So that's why you have to take that 3 cubed as your new scale factor. Okay, thumbs up, thumbs down again. Yeah. Yeah. Okay, So, what?
Let's do an example.
Let's do an example. I think that is a great idea, Eli. So, we have our cone here. Okay, we're multiplying by 3 for the length and the width and the height. So really we're multiplying 27, right? So our volume, we have 15 pi for the volume of A. Okay, we want the volume of B. What are we going to times 15 pi by? 27. Okay, and that is going to give us our volume of B. And 27 times 15 pi is 405 pi. And it's feet cubed. The way I kind of remember it is, since volume is a cubic measurement, right? You're always going to have feet cubed, centimeters cubed, blah, 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 blah. If you're going to have that scale factor between the two, it's going to have to be cubed as well. Okay. All right. If you have questions on that, like during the assignment, make sure and ask, okay? So, last one. Finding the volume of a composite solid. We have two shapes there, right? We have a cone and we have a cylinder. Okay, they're smashed on top of each other. What do? You subtract the volumes or add them? Add them. So work with your partner and figure out the volume of that solid.
Oh. Mr. Desk, Mr. West.
Yeah.
Mr. Desk isn't talking in front of us. I think he should be a better
There you go.
So why do you have two?
They're the same thing. Just pi r squared is big B. So you always you always use this formula, but it comes from that.
Are we supposed to write this down in terms of pi?
Either way.
Here we go. Here we go, Mr. Holy moly. Just now. So we're gonna figure out are you figuring out the bottom or the volume of the lower one of those cubes?
Yeah.
Hold on. Well, you had just put in volume equals 1/3 pi r squared times height, and like you can plug things in to the bottom one.
Not plus H, just that's the same thing.
Okay. What'd you get for the one? I got 180.
Wait, what did you get for the bottom line?
For this one, I got 188. You set it up like that? I know. No.
Cylinder, it's just pi r squared times height. So the cylinder,
Oh, it's not the 1/3. Oh,
no, that's the top part. Yeah.
just a simple error. Just a scratch. Tis but a scratch.
Did you pause it?
Yes. Thank you.
I know.
So what did you get? You got
5,865.4.
That's probably 180 pi. My calculator.
Here. Yeah, that's the same.
Okay, I'm not gonna simplify it yet.
It's wrong.
Don't be sorry. Hold on, Mr. Wentz. Don't do anything yet. I'm trying to go fast.
No. Fixing the problem then.
All right. So, what'd you guys get for the total volume?
216.29.
209.69.
9.
Yeah, I was gonna say.
Okay.
It's point. Oh,
Point 0.29.
Yeah, 29.
Yeah, that's what.
Right, right.
Okay, good. It just depends on how you round.
Okay. So 716.29. Okay. Yeah. Good. Okay.
Yeah.
It says 0.28667776.
So it'd have to be 0.29. Yep.
Wait, wouldn't it be cube, not square? Because it's volume.
Because it's volume, exactly. So anytime you're doing a volume question, it's going to be cubed.
Calculator wasn't
Oh, okay.
Yeah.
Oh, yeah, that looks like.
All right. So, does anybody have any questions? Guys up here. Are we done? Eli,
Yes?
done?
What?
Are you done talking?
Yes.
Okay.
So
You too?
He's freshmen, let me tell you something.
Okay. So, anybody have any questions on this? Volume of cone, surface area of cone? No. Awesome. Okay, if you do, holler. Your assignment's online on Big Ideas. Okay. Most people last period I think got done, so got that going for you. Yeah, I think that's it.